This video will show you how to conduct a factorial analysis of variance using SPSS. As you recall, a factorial ANOVA is one that has more than one independent variable that's analyzed and one dependent variable. In this case, our independent variables are gender and father's education. Our dependent variable is math achievement. So this analysis will be done to determine if there are differences in math achievement by gender, are there differences in math achievement across father's education levels, and if there's an interaction between gender and father's level of education. In other words, do males and females have significantly different math achievement scores at one or two levels of father's education, but not at another level? So in order to do this analysis, we'll go to Analyze, General Linear Model, and Univariate. And in this case, we'll put math achievement in the dependent variable box, gender in the fixed factor box, and father's education revised in the fixed factor box. Then, in terms of what we want on our output, we want to have the plots. And in this case, we're going to put gender on separate lines and father's education revised on the horizontal axis, so that we have males and females being compared on mean math achievement scores based on their levels of father's education. And then we'll add that. And then continue. And then for the post-hoc tests, we're going to select father's education revised and Tukey. Now we're not going to select gender just because SPSS will not run a post-hoc test when a factor only has two levels. So for example, if the gender factor would be significant, all we would have to do is go and look at the means and compare them, and we could say that the higher mean is significantly higher than the lower mean. So then we'll go to Continue, and then we'll go to Options. And in this case, we want Descriptive Statistics, Estimates of Effect Size, Observed Power, and Homogeneity Tests. Then we'll go Continue, and then OK to run the analysis. So in this case, we see that male and female are labeled 0 and 1, and father's education levels are labeled 1, 2, and 3. Now what's important to check out are the numbers for each of these groups, because those numbers should agree with what you see in your SPSS spreadsheet. In terms of the descriptive statistics, those are reported by gender. So in this case, we have the different levels of father's education by male. So for males with fathers who had a high school diploma or less, their mean achievement, mathematics achievement score was 12.8. And then this total score is the male mean across father's education levels for math achievement. So this was the male math achievement mean, regardless of levels of father's education. And then the same thing for females. This total is the average math achievement score for females. And then we have the average math achievement scores for females by high school graduation or less, some college, BS or more. Then here for the total, this is the average for math achievement for all students, regardless of father's education level. Our Levine's test is just barely under the 0.05 level, so it is significant, and we'll have to discuss what remedies we might have to address this. This part is provides much more information than we have previously had with the compare means approach. Notice that we have our our two factors, and then our interaction effect. So for gender, if we look across here, we can see that this result is not significant because this probability is way above 0.05. So we can say that males and females do not differ significantly on mean math achievement scores. Fathers' education levels, on the other hand, do. So we can say that students with fathers of varying education levels do score significantly different on mean math achievement scores. And then the gender by father's education revised interaction effect was not significant. So what this means is that males and females do not differ in some levels of father's education and not others. In terms of the post-hoc tests, we can see that for students whose fathers had a high school diploma or less, they scored significantly lower than those students with fathers who had some college or students whose fathers had a BS or more. And you can see that the mean difference for the first comparison is a little over 4, and the mean difference for the high school grad or less compared to BS or more is a little over 6. And of course, these comparisons are starred. Then the rest of these comparisons are redundant, except for we see that students whose fathers had some college and students whose fathers had a BS or more, that average of almost 2 points of difference in math achievement scores was not significant. And it's not starred here. And then we can see that the probability of significance is way above 0.05. Then in terms of the homogeneous subtests, we can see that the mean math achievement for students with fathers who had a high school diploma or less is a little over 10, and it's in a separate column from the other two groups. So what this means is that students with some college, whose fathers had some college, and students whose fathers had a BS or more scored significantly higher than students whose fathers had a high school diploma or less. Yet, students with fathers who had some college and students with fathers who had a BS or more did not score significantly different from one another in terms of average math achievement because they're in the same column. Then if we look at the profile plots, we can see that we've put the levels of father's education on the horizontal axis, and then the mathematics achievement means are on the vertical axis. And so we can see comparing female and male. Okay, so we can see that across the board, fathers' levels of education did differ significantly, but they did not differ significantly by gender. Thank you.